Hey everyone, and welcome to our next GCSE physics video, and we're going to be talking about magnetism again, but part 2. It's really important that you watch the first video before you watch this one because it's a continuation. So we're going to start by talking about electric motors, and what's important to understand before we talk about how they work is to know that a coil of wire in a magnetic field will rotate as a result of the forces acting on it. So in the last video, we were just talking about a single wire in a magnetic field. But this time, we're talking about a coil. So that's what I'm drawing here. So we've got magnets, and these two magnets obviously are going to cause a magnetic field. And then we've got a coil that's in between them. And obviously we need to remember Fleming's left-hand rule. That's going to help us know what forces are acting on the wire. So for example, looking at the left part of the wire, the current is going in an upward direction, the field is going from left to right, and hence the resulting force is the left part of the wire moves down. And if you do the same with the right part of the wire, it's moving up, and hence it's moving in an anti-clockwise direction. But how does it keep rotating? Because obviously at one point it's going to be parallel. So it's partly because of momentum, but it's also because of a split ring commutator. And what that does is that every half term it switches the direction of the current, and in turn it causes the coil to keep moving in that anti-clockwise direction. We will come back to the split ring commutator later on in the video. So what are the uses of the motor effect? Well, we use the motor effect in devices like speakers. So what we find in headphones. So how does it work? So we've got a current in a wire, and that generates an electromagnetic field. And that field interacts with the magnetic field of the permanent magnet, which I've drawn in grey. And that in turn produces a force which moves the cone outwards. And it's important to remember that obviously this wire is alternating current. So when the current alternates, when it switches, the opposite happens, which means the cone moves inwards. And if the current is rapidly alternating, you can imagine that the cone is going to move in and out rapidly, and that in turn causes vibrations in the air, which then generates sound waves, which we hear as music. So what is electromagnetic induction? Electromagnetic induction is the generation of potential difference caused by a conductor being moved through or exposed to a magnetic field. And normally that conductor is a wire which is connected to a circuit, and the induced potential difference will cause an induced current to flow. So here's a diagram to kind of demonstrate that. So we've got a wire and we've got a magnet, and when the magnet moves into the field, it generates that potential difference. And obviously, once the current flows through the conductor, it creates its own magnetic field which opposes the original change. So what affects the induced potential difference? You can increase it if you increase the speed of the movement, if you increase the strength of the magnetic field, and if you increase the number of turns on the coil. Let's talk about alternating current generators. So they're devices that produce a potential difference. So this time, we've got a coil of wire that's rotating again in a magnetic field. So we've got our north and our south poles, and that's what creates the magnetic field. And current is induced in the magnetic field. The coil makes contact with slip rings, which I've drawn in white, and that in turn makes contact with brushes, which I've drawn in lilac, which connect to an external circuit and causes it to rotate. And that's how we generate alternating current. So we can show this alternating potential difference on a graph like so. So at these 2 points, the induced potential difference is at 0, and that's because the coil is parallel to the magnetic field. So it looks a bit like this. so no force is acting at that point. At these 2 points, induced potential difference is at maximum. And that's because the coil will be at a 90-degree angle to the magnetic field. And obviously with the motor effect law, we know that at 90 degrees, that's when it's going to be the strongest. The only difference is that they will be in opposite directions. But how do we increase the maximum induced potential? So we can do this by increasing the rate of rotation, or by increasing the strength of the magnetic field, or by increasing the number of turns on the coil. So that's alternating current, but how does direct current work? Well, remember the electric motor we talked about at the start of the video? We're basically going back to that. So again, it's a coil of wire rotating in a magnetic field, except it uses a split ring commutator to change the connection every half turn, which basically means that before the induced potential changes direction, the connection is reversed. So current will always flow in the external circuit in the same direction. So every half term, because of the split ring commutator, the potential difference changes and hence the current will flow in the same direction. So what does that mean in terms of the graph? So a graph for direct current will look like this. And you'll notice that it is in the same direction as we just talked about. Finally, we're going to be having a quick look at how a microphone works. So remember what we said about how a loudspeaker works. It's basically the same but in reverse. So instead of electric signals being converted to sound waves, we have sound waves being converted to electric signals. So sound waves are obviously generated by the person using the microphone, and that in turn causes a flexible diaphragm, which is within the microphone, to vibrate. And this is just a quick sketch of what's going on inside the microphone, and that's the flexible diaphragm. So that in turn causes vibrations in the coil, and because the coil is near a permanent magnet, it induces a potential difference in the coil, which causes current to flow in the circuit that the coil is a part of. And varying pressure in the sound waves is matched by the electrical signals, and that's exactly how a microphone works. Thank you very much for watching, and please be sure to watch the rest of our videos.